Using a tape measure, we would have that many significant figures, right? So now that's step 3. Okay. Oh, I didn't. I should have wrote it all the way down here. Now you can go ahead and remember I told you we were going to need the sums of those. So if you wanted to add those now, you can, or you can do it later. And in the directions it says for later, but just so you know. Now step 4 is going to be to determine the centroid of each shape. So first we found the area, and now we're going to find the centroid of each shape. So let's look at shape 1. Okay, so we've got 3 inches by a total of 6 inches. Right, so we've got half the base and half the height, so we should be 1.5 inches and 3 inches, and there it is. Okay, so we're going to do that for each one. Okay, so on the triangle, remember third height, third base, and then of course the same thing on the square right there. So once I do that, so that's step 4. I can do that right there, no problem. Now, step 5, okay, is going to be to determine the distance to the centroid from the X or the Y axis. The mistake people make here, okay, so be careful for it. The mistake is they just measure to the edge of the shape. We want to measure from the centroid all the way back to the axis, okay? Or to this axis, okay? To this axis, to this axis, to this axis. Don't measure to the edge of that imaginary shape, okay? So we're going to do that. So we're going to look at those and we're going to say, okay, we know that one was 1.5. Now, when you look at this is a measurement that is in the X direction, right? 1.5 is, I'm measuring in the X direction. You see that? So I'm going to come down here, and this is my X. So I'm going to say this is my measurement. I'm going to go 1.5 inches, and that's in the X direction. Okay? So the next thing I have is to shape 2, and I have 4 inches, and that's in the X direction.
Why is it square?
Oh, it's not actually. I'm sorry. Thank you. It's not square. And then we have the last one, 4.5 inches. Okay? So we've got those things, and now we're going to do that same thing in the Y direction. So we've got 3 inches to shape 1. To shape 2, we've got 4 inches. And 1.5, right? Got ahead of myself there. Okay. Now, step 6 is we're going to multiply that area times that distance. And so you can see the way I set that chart up is I go ahead and put those multiplications and my equal signs there so I can remember what I'm doing. So I'm just going to multiply. Now, on the PowerPoint, it sets it up a little bit backwards than what I did, right? But we know our order of operations. 2 times 1 is the same as 1 times 2, right? Yeah. So pay attention to your units because we've got an area times a length, and so we get a cube, right? We get a volume, essentially. Right, we get a cube answer there. So I'm just going to copy this down. So the first one is 27. Inches cubed, 18 inches cubed,
45 inches cubed,
40.5, okay. So we got that. Now I can go ahead and remember I told you that you're going to need to sum that. You can do that now or later, and there's a step in here where it says to do both of them, so it's not a big deal. But just pay attention. So now we're going to do the Y, okay. So we've got 3 inches. Here, so we're measuring from here to here is that 3 inches, and we're measuring in the Y direction. Remember that? We're filling that out, we're doing that multiplication. So 54. And then we got 18.
Stuff.
And was it 20? 13. Okay. So that's step 6, is we're just doing some simple multiplication there. Step 7 is where it tells you to sum those things. You may have already done that, especially but you probably had step 3. So we're gonna sum these columns up, and so we're just gonna take those, and we're gonna see that we've got 85.5 inches cubed, and on this one I already know that it's the same for both of them, so I'm gonna write them down. It's not always going to be the same. Okay, not always the same. This one happens to be, and we'll see why. That's called foreshadowing. All right. So now I'm going to add up my areas. 31.5. And those are going to be the same. Okay. So we got that. Now, step 9 is we're going to take that sum product of the areas and the distances, and we're going to divide it by the sum of our areas. So I'm going to take this number, and I'm going to divide it by this number. Okay, so 85.5 inches cubed divided by 31.5 inches squared. Okay. And we're going to do that both places. Okay. So let's do it here, and what that's going to tell us when we do it, so they're doing the X first, so they're doing this one down here first, and that's going to give us, then they're the same. So if you get 0.71, and of course inches, because we've got inches cubed and inches squared, so that leaves us with inches.
What did you say step 8 was again?
Step 8 is going to be to add the areas, and you may have already done that. You could do that really at step kind of 3 or 4 as well. So 9 is to divide this by this. And then the last step would be to go ahead and put your centroid marker on your shape. Okay. Now, the does it make sense question for this shape. If I looked at this shape, does it have a line of symmetry? If that was a piece of paper, could I fold it into 2 equal halves?
No.
How many folds can you make?
Just one fold.
Yeah.
Think about it. Does it kind of look like the Superman symbol? Turned on its side a little bit?
Yeah.
Now tell me if you could fold it in half. Look at it from the side.
Yeah.
Kind of tilt your head a little bit.
I don't know.
Well, it wouldn't
It's
be
not easy.
exactly, because
Yeah, it
that's
is.
2.7
Yeah, it is.
and that's 3.
No, that's 2.7 to the
To the
it has to go
centroid.
all the way over though.
Oh, yeah.
But we don't know if that's 3 or not. It could be 3.1.
Yeah, it is. We saw the measurement earlier, right? So,
All right. But
so
yeah.
does this have, and there's your line of symmetry for this guy. I could take that down and right on a 45-degree angle, okay? And is my centroid on the line of symmetry? Yes. So that's the double check. That's my discount double check. All right. All right. So I went and I said, does that make sense? I can take that and fold it. All right. So now let's talk. So go back to put your mind in inventor mode real quick. Let's go back and put our IED cap on. And remember in IED, when we're doing extrusions, we can add or subtract,
Oh, yeah.
right? So you kind of think about this also has an additive method and a subtractive method. We just did the additive method. So let's look at the negative extrusion method for this. And so they're going to call that the subtractive method. Same things, but we're gonna have a negative area. So let's look at that. So the subtractive method is this. I have an overall big square that is 6 inches by 6 inches. I have a negative extrusion that cut away the corner, okay? It's a triangle that's 3 inches by its base and 3 inches by its height. Okay, so that's a negative extrusion, right? If I was drawing that in Inventor, okay? So I can do that same thing. So same exact steps as before, I'm just doing a little bit different process. So I can do this same thing now with 2 shapes instead of 3. So sometimes using the subtractive method will just save me a little math. So let's look at what that looks like. So shape 1 is our square. Shape 2 is going to be that triangle that's not really there. Okay? That is there. So there's that triangle that's shape 2. Now, we're going to act like that's there when we're doing shape 1. So we're going to take our width times our height. 6 and 6 is 36. Area of shape 2 is going to be removed. Okay? So when we come over here, if I was doing that, if I was going to do that guy here, so I have shape 1, just kind of erase a little bit of that.
I'll make another box.
So if I was going to do this right here, I'd say, okay, we have the area of shape 1 is 36 inches squared. The area of shape 2 is negative 4.5 inches squared. You might, let's put that in a different color so we don't forget. Negative. Right, it's a negative extrusion, it's got to be a negative number, okay? So that's it. Typically, if you mess up when you're doing the negative, the subtractive method as they call it, it's going to be because you forgot to put that number in as a negative, okay? So make sure we put that guy in as a negative on our chart. So same thing as before, we're going to take our half base, half height to get our centroid location of the square, and third base, third height of that. Now you will notice that, right, that the triangle is upside down, and that's okay, right? It's still a base and a height, right?